everybody, it's Professor Mitchell. We're continuing with Chapter 6, and we have reached the last section of factoring. There are a couple more sections left in Chapter 6 after this, but this is the last one that covers factoring. And something that I usually mention before we get to this point, it's pretty important to try to become as much of a factoring expert as you can. Because what I like to say about Chapter 7 is that all throughout Chapter 7, we're going to be factoring our little hearts out. So, practice the factoring as much as you can. It's going to come up in just about every section in Chapter 7, as well as the rest of Chapter 6. All right, so this section is about factoring binomials. First, we're going to talk about factoring the difference of two squares, and then we will talk about factoring the sum and difference of two cubes. And we're still on the same student learning outcome. All right, so let's get into it. The Chapter 5 version of one of these problems looks like this. So hopefully somewhere before you've seen, and I think I have it in the review quiz that I assign at the beginning of this course, the special pattern for multiplying the sum and difference of two terms. So when you multiply two binomials that have the form a minus b times a plus b, which means the two binomials are the same except for the sign in the middle. Well, what happens when you try to FOIL that, I'm just going to try to talk you through it, hoping that you've seen it before, is that the first term comes out to a squared, the outer term comes out to plus ab, and the inner term comes out to minus ab. So those two terms cancel, and then the last term would be minus b times b, which is minus b squared. So normally when you multiply two binomials, you get a trinomial. But in this case, you get another binomial because, again, the outer and the inner cancel each other out. All right, so for example, 4x minus 7 times 4x plus 7. You could FOIL that if you really wanted to, but it's faster to just notice that this fits the pattern that you see here. So all you have to do is square the 4x and square the 7 and take the difference of those two squares. So the square of 4x minus the square of 7 comes out to 16x squared minus 49. So of course the Chapter 6 version of this problem would look like they would ask you to factor 16x squared minus 49. And knowing this pattern, you would come up with 4x minus 7 times 4x plus 7. And of course, if you wrote 4x plus 7 times 4x minus 7, that's exactly the same thing. So it doesn't matter whether you put the plus first or second. All right, so to factor a binomial of the form a squared minus b squared, which is called a difference of two squares, first determine who's playing a and who's playing b. And then the answer is a minus b times a plus b. So let's look at some examples. As usual, I have written these all out on the tablet. So let's switch over to the tablet. And we'll start going through these. All right, so first up, we have x squared minus 36. So this is about as easy as they get for a difference of two squares. So of course, what's being squared here is x, and what's being squared here is 6. All right, so playing the role of a is x, playing the role of b is 6. So if you take x squared minus 36, which has the form a squared minus b squared, the answer is going to have the form a minus b times a plus b. So that makes the answer x minus 6 times x plus 6. It is as simple as that. I personally think that the two easiest kinds of factoring in Chapter 6 are trinomial with leading coefficient 1. That was section 6.2. and this, maybe. Oh, well, grouping is also pretty easy. I don't know. All right. So x minus 6 times x plus 6. And of course, you could check that. I think maybe I'll skip the check on this one. I'll save it for a different one. So let's see what we have next. All right. 49a squared minus 16. So this is just a little bit more complicated. Not really. All right. Notice you have two terms. Notice that the two terms are both perfect squares. What's being squared here is 7a. Don't forget the a. And what's being squared here is 4. All right, so once again, I'm factoring 49a squared minus 16, which has the form a squared minus b squared. I forgot to write down who's playing a, who's playing b. So playing the role of a is 7a. Playing the role of b is 4. All right, so just for variety and to emphasize that it doesn't matter, you could put a plus b, a minus b, instead of a minus b, a plus b. It absolutely does not matter. My answer for this could be 7a plus 4 times 7a minus 4. All right. And again, you can check that one. I think I'll skip the check on this one. All right, next. Oh, I almost forgot something. Bad teacher. I have not been looking for GCFs. We should always, always, always do that at the beginning. So of course, in this problem, the GCF is nothing helpful. All right, so you look at this and you think, okay, I've done a couple of these. The answer is 7y minus 1 times 7y plus 1. So maybe now would be a good time to do the check. I'm going to put a question mark there. Okay, because you might notice something fishy about this. Okay, so again, this is multiplying the sum and difference of two terms. So instead of foiling that, I'm just going to do something squared minus something squared. And look what that gives me, 49y squared. Uh-oh. Minus 1. So close. Okay, but it doesn't quite work because that middle term sign is supposed to be a plus. Okay. Oh, right. This was all about factoring a squared minus b squared. Okay, so how can we fix that? Let me get rid of this stuff because I don't really have room to put a whole lot more stuff here. All right. Okay, so to get the plus, maybe you think 7y plus 1, 7y plus 1. Make them both plus. And I'll put a question mark. Checking that one, I get this one. I think I'll just FOIL because it is not the sum and difference of two terms. 7y times 7y is 49y squared. So far, so good. Outer would be 7y times 1, which is 7y. Inner would be 1 times 7y, which is 7y. Uh-oh. Last would be 1 times 1, which is plus 1. That part's good. Oh, but you see the problem with this, right? Now the middle terms don't cancel each other out. Oh, dear. Well, it was a good thought. Okay, so what have we tried? We've tried 7y minus 1 times 7y plus 1. We've tried 7y plus 1 times 7y plus 1. Well, we could sit here all day. Okay. It turns out, though, that this polynomial is prime. All right. Now, I tried two things, and neither one of them worked. But I really want to try to convince you that this thing is really prime. Imagine thinking of this as 49y squared plus 0y plus 1. And think about how we factored these things in the last section. Remember where we made the little diagram? So suppose I wanted to come up with numbers that add up to 0 and multiply, how does this work again? To a times c, which in this case would be 49, positive 49. All right. Well, the only kinds of numbers that add up to 0 are opposite numbers, right? 5 and -5, 2 and -2, 7 and -7. And the problem with opposite numbers is that they are never going to multiply to a positive, are they? So there is nothing, at least not in real numbers, that's going to add up to 0 and multiply to 49. Okay, so I am now completely convinced that this thing is prime. And I have noticed that every so often they sneak one of these in. So don't let them trick you, and don't let me trick you, because I have been known to put these on quizzes and tests. The sum, we've been talking about the difference of two squares. The sum of two squares is always prime. All right. Okay, so don't torture yourself too much with those. All right, you can just say they're prime. All right, next. I like this problem. What I like to say about this problem is that it separates the A students from the B students. All right. GCF, nothing helpful. Believe it or not, this is a difference of two squares, right? What's being squared, let's start over here, is 4. And is this a perfect square? It is, right? It's not n squared, of course, but what it is n squared squared. So in this problem, playing the role of A is n squared, and playing the role of B is 4. Okay, so how about this time we just write A minus B, A plus B. So that would give me n squared minus 4 times n squared plus 4. All right. So that is the B student answer. All right. And by the way, if you check this answer, it would check. So the check is not completely foolproof. The problem with this answer is that it is not factored completely. Take a look at that and see if there's anything else you can factor. Do you notice anything in there that looks familiar as something you know how to factor? Are you looking at that n squared minus 4? All right, because that is another difference of two squares, isn't it? All right, this is, of course, just the square of n. And this is the square of 2. So this thing is going to break up into n minus 2, n plus 2. Now, what about n squared plus 4? Does that factor? Having a little bit of deja vu. Oh yeah, that's the sum of two squares. That thing is not going to factor anymore. All right, so the full, completely factored version of this thing would look like this. It would be n minus 2 times n plus 2 times n squared plus 4. All right. All right, so that's about everything I can think of to tell you about difference of two squares. All right, so let's go back to the presentation because I have one more thing to show you. And that is the sum and difference of cubes. All right, so back in the old days when I used to teach Math 81 beginning algebra, I always used this example, all right, in chapter 5, something like multiply x minus 7 times x squared plus 7x plus 49. And in fact, in the old version of my PowerPoint, it said something like, remember this example from section 5.3, slide number 11, example E. All right. I had to change that because we don't teach Math 81 anymore, sadly. All right. So let's talk about this real quick. Okay, we're actually going to do a chapter 5 problem here. Okay, multiplying a binomial and a trinomial. I think I might have had one of these on the review quiz at the beginning of the course. There are a few different ways to do these. One way is to start by distributing the x. Okay, so that would give you x cubed plus 7x squared plus 49x. And then distribute the -7. So that would give you minus 7x squared. Look how I'm writing this. Minus 7 times 7x is minus 49x. And then -7 times 49, well, I've got the answer memorized because I've done this problem so many times. It's minus 343. And then what happens? Something beautiful. The x squared terms cancel and the x terms cancel, and you are left with x cubed minus 343. All right, kind of mind-blowing. You multiply a binomial and a trinomial and you get a binomial, all right? So this is a very, very special situation. I have to rig these very carefully in order to get them to work. So what I want to do with this is make it into a chapter 6 problem. I want to show you how to take x cubed minus 343 and come up with this as your answer for factoring, okay? Well, if you look at the pattern here, I think you can kind of see that there is a pattern. We're going to have to talk a little bit more about what the pattern is. Of course, this is the cube of x. This is the cube of 7. Remember, I got it from doing 7 times 49. And so up in what's going to be my chapter 6 answer, I've got the x, I've got the 7, and then I've got like an x squared and a 49, which is 7 squared. So let's talk about how this works. All right, going back to presentation. Okay, that's how it works. So it turns out that not only can you factor the difference of two cubes, and here is the pattern. Whenever you have anything in the form a cubed minus b cubed, it factors into a minus b times a squared plus ab plus b squared. And sometimes I like to read this as aa, ab, bb. And then even though you couldn't factor the sum of two squares, you can factor the sum of two cubes. And the pattern is very, very similar. If you start with a cubed plus b cubed, that factors into a plus b, and a squared minus ab plus b squared. So except for the signs, these two patterns are completely the same. And speaking of the signs, here's a way to remember how the signs work using SOAP, which stands for same, opposite, always plus. So you look at whatever sign is over here. The first sign is going to be the same as what's over here. The second sign is going to be the opposite of what's over here. And the last sign is always a plus. So that works for this, and it also works for this. Same sign, opposite sign, plus sign, okay? Now, the reason that I started way back in the day talking about SOAP is that I used to require students to memorize this formula. All right, but I've gotten softer in my old age. And of course, in an online course, unless I really wanted to police you with a webcam and all this other stuff, I figure you're using notes, and that's perfectly fine. So just make sure that you have these, I'm going to call them formulas, even though I don't really like to call them formulas. Make sure that you have these written down in a place where you can find them, you know, pretty quickly. And then when you need them, you'll have them. All right, so we have some examples, some additional examples for factoring binomials. So let's switch over to the tablet. Let me just get on the right page. Okay. And then after we get through these examples, we will be done with section 6.5. All right, first GCF, obviously nothing helpful. All right, this is definitely a sum of two cubes. This is the cube of x, and this is the cube of 5. All right, now you're talking about perfect cubes. You are probably familiar with, hopefully, like the first 12 perfect squares, right? 1, 4, 9, 16, 25. People tend to be less familiar with perfect cubes. So I'm trying to decide what to tell you about that. You can use your calculator to identify perfect cubes. What I would recommend is that you memorize maybe the first 10 or have them written down. Okay, so 1 is a perfect cube because it's 1 cubed. The next one is 8, which is 2 cubed. Next one after that is 27, which is 3 cubed. And then I'm just going to list the rest of them. 64, 125, 216, excuse me, 343, 512, 729, and 1000. So these are the numbers that you're going to see coming up in your homework. All right, so now let's talk about this pattern. Whenever we want to factor a cubed plus b cubed, that factors into a, b, and then a, b, b, b. And the signs get filled in with soap. Same, opposite, always plus. All right, so in this case, playing the role of a is x. Playing the role of b is 5. So my answer is going to be x plus 5 times x squared minus 5x plus 25. All right. And you know what? Let's check that one. Why not? Okay, so I think this is the answer. And for the check, we would just do something similar to what we did in that other multiplication problem. When I distribute the x, I get x cubed minus 5x squared plus 25x. And when I distribute the 5, I get 5x squared minus 25x plus 125. That cancels, that cancels. Woohoo! X cubed plus 125. All right. I'm not going to lie to you. People do struggle a little bit with sum and difference of two cubes. You know, it is a slightly more complicated pattern. It's just practice. Almost all of math is practice, just practice, practice. Okay. All right, so let's look at the next one. Oops, there we go. 8 minus a cubed b cubed. Okay. GCF, no help. All right, so are these things perfect cubes? I think they are. This is the cube of 2. And this, can you see how to fill in that blank? You would just fill in that blank with an A, B. Okay. All right, so this is where it gets a little confusing because I'm using A and B, and I did that on purpose. I didn't want to just hide from it and not do it because they do use A and B in some problems. Playing the role of A from the formula is 2. Playing the role of B from the formula is AB. All right. Okay, so this is a difference of two cubes. Whether it was a sum or a difference, it would go AB, and then AA, AB, BB. All right, so now I fill it in with who's playing A, who's playing B. This is going to be 2 minus AB. Okay, now I have to be a little careful over here. Playing the role of A is 2. So this needs to be 2 squared, which is 4. Okay. A times B. Oh, I forgot to fill in my signs. Same, opposite, always plus. All right, so AB, playing the role of A is 2, playing the role of B is AB. So this is going to be a plus 2AB. All right, and then finally B squared. Remember who's playing B? AB is playing B. All right, so you have to write that term as A squared B squared. If you need to pause the video for, a minute or 2 or 3 and process that, it's totally understandable. I'd say on a scale from 1 to 10, this one's maybe about a 7. Okay. Really, a lot of math, in addition to practice, is just patterns. It's, the same pattern over and over and over again. It's just sometimes it looks really different. All right, next. This is one of my favorite examples. Okay. Y cubed minus 64y. So what do I do first? All right, hopefully you said GCF, because this time the GCF is going to pay off. GCF is y, isn't it? All right, so pull out a y, and what do I have? I have y squared minus 64. Okay, so I will proudly admit that I made up this problem, and I made it up to be kind of tricky. I probably wouldn't put one like this on a test, although I might. This is supposed to look like a difference of two cubes. It is not a difference of two cubes. It is a difference of two squares with a little GCF thrown in. All right. So this is actually, I think, an easier problem than letter B, as long as you remember to get that GCF out of there, because now that's just a little old difference of two squares, right? Those are easy. Y squared minus 64 factors into y minus 8, y plus 8. Remember that? And that's it. We're done. All righty. That is my answer. One more factoring example. And then we will be on our way to being factoring experts as soon as we've done all the homework. All right. You don't become a factoring expert by listening to me, do this. You become a factoring expert by doing the homework. Okay. All right. So first step, GCF, right? And this one also has a GCF. 250 and 128 are both even numbers, which means I can at least pull out a 2. And in fact, as far as the number goes, that's all I can pull out is a 2. And then a to the 4th and ab cubed, I think I can pull an a out of there, right? All right, so what does this look like after I pull out 2a? I am left with 125a cubed minus 128 divided by 2 is 64. AB cubed divided by A is just B cubed, right? Okay, so now that starts to look a little bit more comfortable and familiar, that 128A cubed minus 64B cubed. That is definitely a difference of two cubes. What's being cubed here is 5A. What's being cubed over here is 4B. Okay. Now, don't forget about your GCF. Sometimes even my A students, after they factor out the GCF, they kind of forget about it and it gets lost. All right. Okay. So what would be parked next to the 2a would be my factored out difference of two cubes. So it is a difference of two cubes. So this is going to look like a minus b, a squared plus ab plus b squared. That's the pattern. Playing the role of a is 5a. Playing the role of b is 4b. So my binomial factor is going to be 5a minus 4b. And then over here, the a squared is going to become the square of 5a, which is 25a squared. The ab, that's going to be 5a times 4b, which is 20a, 20ab. And then the b squared, that's going to be the square of 4b. That's who's playing b in this problem. So for that, I'm going to write 16b squared. Scale of 1 to 10, this is a 9.5. All right. This is about as hard as they will ever get. All right, just in case you're freaking out. But now we're done. The answer is right there. 2a times 5a minus 4b times 25a squared plus 20ab plus 16b squared. All right, so I would like to end this presentation by finishing. Oh, and that's a little troll face. That's supposed to go with letter C because that was me being tricky. When I teach this class to face-to-face, the little troll face comes up right after we go over letter C. All right. Finishing up the list of steps for factoring a polynomial. Step 1, factor out the GCF. And I'm very excited to share with you that I updated one of my memes. I told you I was going to try to get some stuff that was a little more up to date. I did make this one. I Googled factoring memes, and believe it or not, there wasn't really a whole lot of stuff there that wasn't kind of lame. So I made this one. Don't just jump right to the newest factoring trick. Sometimes that's the temptation. Always, always, always start by looking for a GCF. Okay, step 2, how many terms does the polynomial have? If it has 4, that is factoring by grouping. If it has 3, then you can either factor that by trial and error, like we did in 6.2 and 6.3, or you can use the AC method, which a lot of people tend to like. And now we know what to do when there's 2 terms. If there's 2 terms, it's likely either a difference of 2 squares or a sum or difference of 2 cubes. And finally, you don't have to just cross your fingers and hope you're right. You can always, always, always check your answer. All right. And by the way, have I ever mentioned this before? I will be more generous with partial credit on your written work if I see a check. All right. Check is not absolutely mandatory, but you kind of skip it at your own risk. You know, you're hopefully most of your answers will be correct. But if you do get one wrong, I'm going to try to look at your written work and see, you know, if there were 8 things worth trying, did you try 7 of them? All right. I would give you most of the credit for that. If you tried 4 of them, I would probably give you half credit. All right, and that's it. So you do the homework and you will be a factoring expert. So next time we're going to get into applications of factoring. So we'll see you then.